section 5.2, page 2. So in example 2, we're asked to evaluate the definite integral geometrically. My goodness, suddenly that was a hard word. Okay, so we're used to doing it with making rectangles, but when you see geometrically, there's all sorts of different shapes. So we're going to start with a rectangle. I just see the basic problem I'm used to, where now with the definite integral, I'm finding my beginning and ending x1 to xn range in the integral symbol. I've got my function in front of dx. So basically y or f equals 3. Well, if there's not a variable, then we just have a horizontal line at height y equals 3. So when x is 0, we have a height of 3, right? If this is 2 and this is 4, then 3 is in the middle. When x is 1, we have a height of 2. When x is 2, we have a height, I said 2, but a height of 3. When x is 4, when x is 3, we always have this height of 3 because we have a constant function at 3. Well, if I'm evaluating from a equals 0 to b equals 4, then I want from the x-axis in that range underneath the curve. And this case, it created a rectangle. So my geometric shape is a rectangle, which we find the area by multiplying length. I know the length because it's 4 minus 0 times the width, which in our case is actually the height. And since we have a height of 3, I'm going to multiply 4 times 3 to get the area of the shape to be 12. Now in example 3, when we are evaluating a definite integral, we know it's definite because we have a and B range that we bound our curve within. When I'm asked to do it geometrically, this time it's going to turn out I'm going to have a triangle. I'm actually going to have more than one triangle, which is why the word is plural. Don't forget the formula for the area of a triangle is 1/2 the base times the height. So my suggestion is we focus on, our graph is going from -1 to 4. So I'm going to come kind of highlight from -1 to +4. I need to graph this shape because I recognize that it's in the y equals mx plus b format where I have a y-intercept of 1. So I'm going to come to my graph and draw my y-intercept of 1 and then use a slope of -1/2, which is to go down 1 over 2 and make my next point. Down 1 over 2 and make my next point, so that I've got my y-intercept and these other points that are going to give me my shape. So if I had had the region I wanted in the x-axis highlighted and my graph highlighted, you can see that this encloses 2 separate triangles. Now, we had talked about net area before, that if any of the area that you're shading is above the x-axis, it will be positive. So I drew it in green and then put another version of this over here. But if any of the area you're drawing is below the x-axis, then it's negative, and I just superimposed that same shape over here. So I need to find the area of my triangles. I'm going from -1 to 2. So 2 minus -1 is a width of 3. The base of my triangle is 3. Now, the height right here, this, it's hard to see, but this is a 1, this is a 2. This is the height. It's somewhere in between 1 and 2, but I don't want to just guess. To figure out what this height of my triangle is, I need to come back to my formula and plug my x value of -1 into this formula. So I've got -1/2 times -1 plus 1, and it becomes +1/2. So the area of the first triangle is 1/2 the base of 3 times the height of 1/2, which is 9/4, and I got a positive number, which I was expecting. Now I've put in a plus for the next triangle, but we'll talk about that in a moment. So I'm going from 2 to 4 because I can see that's where it crosses the x-axis. If I wasn't sure, I could actually plug 2 into this and the 2's would cancel to give me -1 plus 1, which is a height of 0. So I know that I'm going from 2 to 4. So 4 minus 2 is my base of 2. Again, I need the height. And this one actually looks like it's negative 1, but I don't want to go off of my visual. I need to be sure. So I'm going to come to negative 1/2 x and plug 4 in because that's the x value I'm above. I've got that plus 1. And yeah, the math did end up being a negative 1. Now here's where things can go two different ways. I've gone ahead and talked about the height being positive 1 because I'm just thinking relative height. And so I would multiply 1/2 my base of 2 times my relative height of 1, and I would get a positive 1. But I put a plus here. And I know that this area is below the x-axis, so really I need to subtract 1. Or this is where I was saying things can go two ways. Maybe you actually used a negative 1 here, and so then you had plus negative 1, and we're ending up with the same problem. I need to take my positive 9/4 area above the x-axis, and I will be subtracting 1. But since fractions need the same denominator, I'm using the disguised form of 1, which is denominator over denominator. So 9 minus 4 is 5, still over 4. And I got a positive answer, which I was expecting because visually the green triangle looks much bigger than the red triangle. But sometimes our degree of accuracy with sketching is hard to tell. But you'll notice if I took the absolute value of one triangle, in this case the green, and compared it to the absolute value of the other triangle, in this case the red, 9/4 is still bigger than 1. Okay, so two other things to talk about with definite integrals. Displacement versus total distance. In section 5.1, we were given velocity and we used it to approximate the distance or the position by approximating the area under the curve. So now that we know that integrals represent the net area, before in 5.1 we only had positive area, we now need to handle functions with positive and negative values to discussing displacement versus total distance. Let's begin with displacement. The difference between the starting and end point of positions of an object. So because the way we just have integration to get the change over time, we have velocity. But if you wanted the actual distance, we need to integrate the absolute value. So we would have had a case like 9/4 plus 1 and had an answer much larger than 5/4. Think of it this way. You're running a race on a circular track. You're going to start where you finish. Your velocity is 0. But if we want to talk about how far you ran, yes, you started and stopped at the same spot, but maybe you ran 5 miles. So it's a kind of a case where, are we taking something like 3 miles minus 3 miles to get 0? Or the absolute value of 3 plus the absolute value of negative 3 to get 6. So hopefully that kind of helps clear that up.